Right, for this homework assignment video, we'll do 55, 71, and 87. So the two methods that I emphasize in terms of solving log equations is one, if you have a logarithm set equal to a number, simply put it into exponent form and solve accordingly. If you have a logarithm set equal to a logarithm with like bases, then the logarithm and the base, quote unquote, cancel and you set the arguments equal and solve accordingly. In this case, for number 55, we see we have a logarithm set equal to a number. So we go ahead and put into exponent form. Our base is 2 to the fourth equals the argument, which is x plus 25. And then now at this point, it's just a linear equation. 2 to the fourth is 16 equals x plus 25. Subtract over 25. X will equal -9. Now we have to make sure that -9 plugged in will give us a positive argument, and if we do, it would give us a positive argument. The reason it has to be a positive argument is because 2 to some exponent will always give you a positive number. So logarithm arguments are always greater than 0. If you plug in your variable and it makes that argument negative, then that you cancel that or discard that solution. 71. We have two logarithms separated by subtraction. Those logarithms have the same base, so we can condense them. We have log base 2. The first logarithm is a positive, the second logarithm is a negative, so the positive logarithm, that argument, which is x plus 2, goes in the numerator when we condense it, and the second one is a negative logarithm, so that argument goes in the denominator. That's based on our quotient property, equals 3. And now we have a setup of a logarithm set equal to a number, which means we put it into exponent form, so our base is 2 to the third power equals our argument, which is x plus 2 over x minus 5. So to tackle this, we're going to have to multiply the x minus 5 out of the denominator. First, I'm just in the interest of saving space and consolidating time on this, I'm going to just change that 2 to the third to 8. We're now going to multiply by the denominator, x minus 5, on both sides. When we do that, that gets rid of the denominator right there. On this side, we can distribute the 8 in. As we see, we have x's on both sides, so we're going to have to get rid of those parentheses to get individual terms on the left-hand side. And now it's a matter of getting x's on one side and constants on the other. So I'm going to subtract the x over. Easier to deal with a positive coefficient, so that's why I subtracted the negative x. It's a negative 40. I want to move that to the other side, so I add 40 both sides. 40 plus 2 gives us 42. Divide by 7. X equals 6. And then we want to check to make sure that 6 doesn't make either of the arguments negative. So I plug 6 in for here. That would make it 8, which we're good. And this would make it 1. 6 minus 5 is 1, so we are good there as well.